In our previous video, we introduced stated preference data and described how it's different than revealed preference data. And in this video, we're going to explore how researchers design choice experiments to collect the stated preference data that we described previously. And the main idea is that by coming up with data that's been tightly controlled in its collection, that will allow us to make better causal claims or policy experiments because we set up the data collection in a way where identification is very transparent and analysis is much simpler to execute. So I'll walk you through how some of my own published research has used these choice experiments and how we collected our data. And then we'll also talk about different ways that we can set up the choice experiment to get greater or less information on preferences. So the paper that I'm referring to is published in the Journal of Econometrics in the year 2022, and we are looking at stated preferences for location choice in the United States. So the question that we would ask the respondent is, what is the percent chance that you would choose to live in each of these three locations given their listed characteristics? And then crucially, assume that the locations are otherwise identical. So this is a way to say we only care about these covariates of interest. Everything else you should think of as being the same across the scenarios. And this is the first scenario. So they have option A, B, and C, and A is stay where you are. And then we can specify how far the move would be if they moved, whether they would have family nearby, and what their income would be. And then we ask them to report a probability. So some number between 0 and 100% about the percent chance that they would choose to live in each of these locations. And we could also just have just mark the one that you would do. Or maybe we could say rank order these. So those are different ways that we can measure our y variable. And I'll get into that momentarily, what the implications of that are. And then we have another scenario which has the same three covariates, but there's different values in each of the columns. And then they might give a different probability for that. And then we can just repeat these different scenarios over and over again. And that can give us, as long as we have enough variation in these x's, that can give us the preferences that they would have for each of those covariates. And as I was alluding to earlier, there's several types of stated preference choice experiments. So first we could do a discrete choice experiment where we just say, mark the one that you would choose. So if I have three options, then the y variable is going to be a vector that sums to 1 and only contains 0 and 1 values. Alternatively, I could say rank order these in the order of your preference. And in that case, I would get as my y vector, I might have, if j is 3, I might get 1, 2, 3. I might get 1, 3, 2, etc. And then finally, I could do what you saw on the previous screen, which was elicit a probability. So instead of providing effectively up here in the discrete choice model, they're saying 100%, 0%, and 0%. Maybe they're going to say 49, 50, and 1. But the probabilities just have to sum to 1 or sum to 100%. And so we'll get into it later of how much preference information we can get from each of these types of choice experiments. But the end idea is that each of these is going to provide increasing amounts of information about how intensely they prefer certain aspects of the choice. What are some general considerations if you're going to be designing these choice experiments? You need to keep the number of choices limited, so no more than 4 alternatives at once. You also need to make the choice setting realistic so that the respondent answers in a natural and hopefully truthful way. You do need to have some sort of status quo or reference option. And again, that's just more to keep it realistic and grounded in what the respondent is currently experiencing. You should only vary a small number of attributes at a time. Hopefully that's somewhat obvious. If I go back to the prior slide, it's not going to be helpful to have the consumer try and weigh out the pros and cons of this scenario if they have to do 6 different dimensions to the choice. And then we also need to instruct the respondents that they should only think of the alternatives as differing in the ways that we have specified here. And then as we're going through these different scenarios, we might have blocks where in this block we're looking at the presence of family as being an attribute. Maybe in another block, we're going to look at the crime rate of the neighborhood or the commute distance. And we want to randomly assign respondents to consider different blocks of these attributes that we're randomizing so that we can get consistent estimates of the preferences. As far as identification and design of the experiment, we're going to need independent variation in each attribute in order to identify preferences. If we have 3 attributes, we're going to need 4 choice scenarios with independent variation if we want to identify linear preferences. If we want to identify more, like nonlinear or interaction effects, then we're going to need more scenarios. And there's a large literature that you could look up that talks about de-efficient or de-optimal designs. We won't get into it in this YouTube series. Another question might be, why should we elicit probabilities instead of doing a yes or no or a rank ordering? And the main idea here is that eliciting probabilities is going to allow the respondents to express uncertainty about anything that is not fully specified in the choice experiment setting. So this is called resolvable uncertainty. So by eliciting probabilities, you're allowing the respondent to express this uncertainty. And this is going to give more information than imposing a binary choice being made. And the way to think about this is that if I have 2 alternatives that are highly preferred and a third that's definitely not preferred, then the individual is close to indifferent between the first 2. And so this will be better captured by choice probabilities as opposed to 0-1 discrete choice experiment or rank ordering. And it's an empirical question whether this resolvable uncertainty even exists. If there isn't much resolvable uncertainty, the respondent can always fall back on just putting 100% for this option, 0% for the others. So that is a little bit about how we design these experiments and how we can ensure that we have appropriate identifying variation for the preference parameters that we want to estimate. In the next few videos after this, we'll go into detail about how we actually estimate discrete choice experiments, rank ordered choice experiments, and this stated probabilistic choice experiment that I just introduced here. Hopefully you're as excited about this stuff as I am, and I hope to see you in another video.